Hello viewer, myself Professor Harel Thomas. I am professor in Department of Applied Geology, Dr. Harisingh Gour Vishwavidyalaya Sagar, MP. Today I will discuss about migmatites. Metamorphism, deformation and magmatism are the three main internal processes within the earth. It is known that melts of basaltic composition are generated in the low velocity zone, also called as asthenosphere, which is nearly 70 km under the oceanic crust and nearly 180 km under the continental crust. Other source region of basaltic magma are divergent and convergent lithospheric boundaries. Melts of granitic composition can only be generated in the continental crust. Some dozen mechanisms of magma generation have been proposed by Yoder in 1962, but every one is simply a change of pressure, temperature and X, that is composition. Unlike a pure phase, a rock melts over a range of pressure and temperature, and the liquid produced on partial melting does not have the same composition as that of the original rocks. This is true for both mantle and crustal rocks. The curve showing beginning of melting of a rock is called solidus, and the curve above which the rock system is completely liquid is called liquidus. Melting or partial melting occurs when temperature increases or pressure decreases, or if activity of H2O, that is water influx, occur. The effect of these three agents of melting, which are also of metamorphism, can be easily understood with reference to figure. It's shown dry and wet solids curve. S denotes solids, L denotes liquid of a crustal rock, of mantle rock or a mantle rock. Material A is below the solidus and is completely solid. By changing any one of the agent, we can perturb the situation so that melting takes place. First, when we increase the temperature without change of pressure, a rock is partially melted, but increase in temperature result into decreases in the density of the crust or mantle rocks. This would result in uplift of the earth's surface, meaning increase of pressure. But Erosion would then decrease the pressure. Second, decrease in pressure in a crustal segment as during crustal thinning would also cause melting. This is familiarly called decompression melting, exemplified by basaltic eruption at the mid-oceanic ridges when the point A moves adiabatically thermally insulted from its surroundings like a plumes. Melting ensures melting also takes place when influx of volatiles, mainly H2O, occurs during metamorphism. Mainly H2O occurs during metamorphism. This would reverse the slope of the solids. This wet solidus or H2O saturated curve is characterized by temperature reduction as P increases because of the vapor effects at high pressure. The term migmatites was introduced by Sagar in 1907. The migmatites are coarse-grained, heterogeneous, and megascopically composite rocks comprising proportion of migmatites or magmatic-looking rocks and portion of metamorphic rocks. The portion contain quartz and feldspar and hence granitic or felsic in composition. The light colored components or leucosome is also designated neosome, newly born. The metamorphic portion is dark colored and contain biotite and other minerals such as garnet, cordierite, gaderite with little amount of quartz and plagioclase. Presence or absence of index minerals in melanosomes or paleosomes, the dark color layer. We can also classes migmatites as a garnet absent migmatites or garnet bearing migmatites or cordierite, selimanite, migmatite, etc. Micas and amphiboles in these migmatites show preferred orientation unlike those of the leucosomes. The parent rocks, whether metapelites, schist, gneisses or amphibolite, is designated paleosomes or meiosomes. Meiosomes gneisses differ mineralogically from deformed leucosomes in that it contains abundant biotite, garnet, kyanite or selimanite. The paleosomes have a different relationship with its melt fraction, that is newly formed veined materials. The dark colored metamorphic components of the migmatite is known as melanosomes. Melanosomes are sites of melts extraction and represent unmelted or restitites. Baumann in 2001. If melting occur in situ, then one can calculate or determine the parent composition from the chemistry, mineralogy and volume relationship of the melanosomes and its leucosome, because melanosome plus leucosome equal to paleosome. The mixing of paleosome or melanosome give rise to various type of migmatites depending on the structure of pre-existing rock if the dark and light color occur in nearly planar bands or few centimeter to even meter in thickness, these migmatites within regular layers of leucosomes are called banded gneisses or vinite or stromatolite. If leucosome appear in layers parallel to S surface and in veinlet, the migmatite is called diconite. When migmatites have discrete leucosome, as if anastasis was in the initial stage, such migmatites are called metatext. If light bands so folded of various dimension, they called as folded migmatites. If the dark colored portion has the appearance of breccia embedded within the leucosome, this migmatite is called agmite. If the dark portion is on a vanishing stage and it is recognized by dark celeron within the granitic portion, this migmatite is called nubolites. Some geologists call the nubolites migmatite as a dextite. These migmatite nomenclatures are after Meharent 1968 and Ursworth and Macmillan. The migmatites are devoid of muscovite plus quartz paragensis and are found in higher grade metamorphic terrain in association with granitic bodies. This type of geological occurrences is reported from all over the world. Clearly, the migmatites belong to the upper amphibolite phases where muscovite is no more stable in quartz bearing rocks. Especially peltic rocks usually partially melts and form migmatites. Although migmatites are formed in the upper amphibolite facies rocks, they also occur within gaulite facies rock and also associated with granites. Migmatite rocks, however, show no spatial relation to granitic bodies where granite is absent. Migmatites are abundant, and where granite is present, migmatites are not present in its vicinity. Sluderholm in 1907, followed by other geologists, suggested that the leucosome of migmatites are formed by partial melting of pre-existing meta-sediments, and mechanism is called anastasis by Sluderholm in 1907. The course content on migmatites begin with introduction followed by the migmatites, type of migmatites, mineralogy and phases of migmatites. Along with the support of experimental data, we can conclude that migmatite usually formed at upper amphibolite phases where muscovite is no more stable in quartz bearing rocks. In next modules, I will cover the crustal melting and granitic magma, which is also a part of migmatites. Thank you very much.